Last year around this time, I made a video called Year in Review 2023, where I just go through the big events of 2023, maybe offer some musings as to what I learned and what worked and what did not work. So I thought I would do the same for 2024. I originally wanted to make a Christmas video, but I found it kind of difficult to make, any content yesterday because we were busy giving gifts and seeing family. So the day after Christmas we'll have to do. Overall, I thought Christmas was pretty good this year for me and my family. I gave my Harvard coffee mug to my mom. I gave my MIT coffee mug to my dad because my dad's more science oriented anyway, so I figured MIT should go with him. And then I gave my brother my brown book. So in my last video, I showed you my book. It says brown. It's, it's smaller than these guys. It's also hardback. He likes those things, and I don't get as much. It was originally for me. It wasn't supposed to be a gift. I should lead with that. But I needed to get him something, and I couldn't think of what to get him. And I knew he liked those types of books, and I wasn't super sold on it. So it just made sense that it should go to him. So I gave him the book. He really liked it. And I got this mug for Christmas. And I got other things too, but this was like the highlight gift that I got. I don't really use coffee mugs that much. In fact, I don't really even drink coffee. But, I mean, having little things like this, and also hats. I like hats. I collect them as souvenirs. So you can see on the front I have my my profile picture for the YouTube channel. The background is my banner, which is supposed to be like a fractal starry night. I can't really remember what I chose for my banner. Or the reason why I chose it, like what I searched for when I chose it. I think that's what it's supposed to be. And the quote says, "Don't believe what someone tells you, believe the math." I don't know who said this quote. My mom doesn't know either. She asked me who said it, and I said, I don't know. I would have preferred maybe a quote from maybe me on the channel or some scientist that I really like Richard Feynman. I like Richard Feynman. But it's still a good quote. Yeah, it's a mug. The profile picture, I don't think I've ever talked about on the YouTube channel, like why I chose it, what it means, and why I like it. There's a couple reasons why I chose it, and it just made sense. The first reason is that this constant, this number, the Euler-Mascheroni constant, was or still is my master's advisor that I did my thesis with. That's his favorite number. It's also one of the great part of one of the great unsolved math problems in recent history. It's whether or not this number is rational or irrational. And I believe the story goes, you'll have to correct me because my math history isn't the greatest. I think it was the chair of the math department of Cambridge, I want to say, who put a bounty on this question. He wanted an answer to it, and if anyone could answer it, then he would abdicate his his throne. He would leave the math department, quit being chair. And he put forth that challenge to his department, and no one was able to prove it, so he never left his chair. I don't know if that's like an urban legend or something. I'm not really sure why people would... It seems kind of... I don't know, that makes me think like what kind of chair he must have been. Like, he goes, "I'll quit my job if you solve this problem." And then everyone voraciously starts to try and solve the problem because they don't like the guy, but I don't know. It's most likely irrational if I had to take a guess. I mean, I think there's a result out there that says that if it is rational, then the denominator is, I don't even know how many digits long it is, but it's a huge, huge, huge number. You can read about it on Wikipedia. But that's the second reason. The third reason is kind of silly, is because the letter actually, the Greek letter here, gamma, actually looks like the first letter of my first name. So that's the third reason why I chose it. Felt appropriate for the channel. What else can I say? For the past 7 days, since I've been here, I'm at my parents' house right now. This table is my mom's sewing station. The sewing machine's gone. You can see her sewing material there. I've been working here for the past 7 days since I first got here. And over those 7 days, I said that I wanted to do an MIT open course lesson on their website. And I found Scott Sheffield's Theory of Probability course. And I've been working on that nonstop for the past week. And I put all the notes in this Harvard book. And I finished yesterday on Christmas, like Christmas night. I finished it. So I tried to take care of this as best as I could, as you can see on the sides. I don't know how well you can see this, but there's no like, well, a little bit there you can see of paper that's been crumpled up. But I tried really, really hard not to do that. But it's all here. All lectures are labeled. I tried to draw a lot of pictures if I could, but ultimately some of this stuff is pretty hard to draw, and I have to sit down and draw good pictures, and I was more interested in just taking the notes. But anyway, this first couple lectures, I breezed through this pretty quickly because I remembered all this from when I took probability theory. This is a graduate level MIT course, by the way. They use the Durrett probability book, which I don't want to be negative or anything on the channel, but that book, since it's used in a graduate level MIT course, they make a lot of typos for that book. I don't know. I saw several typos in it, and I was a little bit annoyed by that. But either way, it's still a good book. Still some things. I didn't prove everything. I should mention that. But I filled this thing up all the way to the end. Like, there's not a single sheet of paper that has wasted space. I mean, I don't count this as wasted space. I mean, spacing is important. You want to make sure that everything is, fits together nice. And that it's easy to spot Holder's inequality and be able to read it and have it make sense. So, if something here was pretty clear to me, like Holder's inequality, I've done that in measure theory, then I didn't include the proof, because I've done that in measure theory. I wanted the proofs to be more measure theory based, unless it was like a really important theorem and it didn't take that long to do. Fatou's lemma, for example. I did not prove Fubini's theorem. I don't think it's here on this page. But either way, I'm not going to go through this page by page, but I tried, as you can see, I tried to make sure everything here was really nice and clean, so that when I go back and look on this, everything here makes complete total sense. But I did basically 39 lectures of Scott Sheffield's course on MIT, took all the notes. I even went rogue a little bit and started doing stuff in the book that I thought should have been there, that wasn't in the lectures. He didn't prove a lot within the lectures, so if he had a theorem that he stated, I went into the book and proved it there, or just wrote down the proof that he had. And the biggest thing that I noticed from doing all this is that I can do 39 lectures of probability theory in about a week if I work nonstop, which makes me think, like, if someone was truly dedicated to this stuff, like, how much could they do on their own if you just say, okay, I want you to do a course in statistics, complex analysis, whatever. Like, a person that's truly self-motivated, like, how much math could they learn in that short amount of time? But I should also mention that I have seen a lot of this material before, so seeing it a second time, you do go faster. But still, we're comparing, like, 39 lectures compared to 1 week. And if you have the time, like, how much could you actually get done? Another question is, how much of it do I actually understand? These early pages I understand pretty well. There's nothing crazy going on here. But when we get to, like, Brownian motion, then it starts to fall apart. I need to go through that again to make sure, because I wanted a deeper understanding of Brownian motion. That was part of the reason why I settled on probability theory for this notebook. Second Borel-Cantelli lemma. Probably my favorite theorem from real analysis, or at least the first one is, but I mean, they go hand in hand, second and first Borel-Cantelli lemmas. Now, if you ask me to do all of this from memory, then it may take me a little bit longer to commit it to memory, but my analysis professor kind of forces us to do that a lot of the times. Kolmogorov 0-1 law, I remember that. This takes me back 2 years when I took probability theory. I missed that class. Martingales, I miss martingales, learning about them. I wanted to understand all that stuff. The one thing that I regret not doing when I went through all this is more examples. I wanted there to be a lot more examples here. Also, the Radon-Nikodym theorem. At some point in here, hold on, maybe I can find it. Let me zoom ahead. Hold on, I want to make sure I don't be gentle with the paper. These are stopping times. I don't want stopping times. What I was going to say about Radon-Nikodym theorem. He doesn't prove it in the lectures for a good reason. He doesn't prove it in the lectures because it requires a lot of, here it is. It requires a lot of backstory in measure theory that wasn't developed up to that point. But I was determined to include the proof because I think it's important for probability theory. So I had to prove like 3 separate results and develop this notion of signed measures in order to do it. And it killed a lot of paper. And that real estate could have been probably used to prove some other really important things like the Markov property. But I wanted to include Radon-Nikodym. So there's the statement of the theorem. And the way they do it in the book pretty much starts here. So we develop signed measures. Now this stuff, though, I did enjoy. I understood everything here because I've seen it in my measure theory course before. We have some lemmas, some nice pictures. And then we get to the Hahn decomposition theorem. Yeah, I can draw pictures for this pretty well. I understand this enough to where I can just think of an integral when you want to think of signed measures, or at least in the beginning. Mutually singular, so we have the Jordan decomposition theorem. And then eventually we get to the Lebesgue decomposition theorem, which is here. And then once you have Lebesgue's decomposition theorem, Radon-Nikodym kind of just falls out of it. In fact, a lot of people, I think when we did this in the measure theory course, this was Radon-Nikodym. Like they were combined. And then eventually you have this proof of Radon-Nikodym. But it requires all 3 of those decomposition theorems to make this work. Anyway. And eventually we get back to conditional expectation. I don't really like the way the book presented conditional expectation. I like the way we did it in the course when I took it the first time. But either way, it's fine. It's just me being particular. Anyway, I've spent way too much time on this. This is my biggest accomplishment, recent accomplishment so far, so I'm kind of proud of it. But I did fill up the whole thing. I do finish on the last page, so I guess I'll do that over here. You can see we finished proving the strong Markov property for Brownian motion. And I put a little message at the end. And with that, the course is complete. So I know that I didn't spill over into another notebook. But there it is. And now I need to figure out what I want to do with the MIT folder. This smudge still bothers me, by the way. I haven't written anything in it yet. But I'm going to find a course on the MIT webpage and do it. I wanted to do like complex analysis, but I feel like there's something better that I could do with it. Because I've taken complex analysis basically twice, or I guess you could argue 3 times now. So, we'll see. I'll figure out what to do. 2024 in review. What can I say? The year started out taking functional analysis 2, which I had some of the hardest homework problems I've ever had in that class. Those homework problems I got stuck with were super bad. I think there's a video on my channel called the Blaschke-Santalo theorem. There's another video called bounded mean oscillation. That I think I was in those videos. I was really stressed out about my homework. I don't know why, but that semester was bad. I was crying at night, like, I can't do my homework. Someone help me. And then not even AI can help you with that. AI's like, good luck, pal. This is not what I was built for. I was built for writing short stories about Spider-Man or something like that. But I ended up getting an A. Someone in the comment section actually made a suggestion how to solve something, and it helped me out, and I was able to get an A. So thank you, kind stranger, looking out for me. What else? I mean, after that, I kind of started doing research over the summer. But it got quickly derailed because I took 2 summer courses, and one of the summer courses was taught by a guy who, I don't know why, but he had 5 weeks. The summer course was only 5 weeks, and he packed in probably a semester's worth of linear algebra in 3 weeks. And then the 2 remaining weeks, he talked about topics and convergence for like real analysis. I think the purpose of the course was to help people with their qualifying exams, but I don't think it worked because everyone that took that qualifier exam failed. But either way, that course was very dense, and the homework problems were very tough. And I remember he gave us 8 homework problems. These were the linear algebra problems, and there were 8 of them. And they were organized in ascending levels of difficulty. So question 1 is very easy. 2, a little bit harder, you get the idea. And question 8 is the, oh my God, don't even talk to me. And I remember my advisor saw that list of 8 homework problems, and he came up to me. He knew I was taking the course. He came up to me. He goes, hey, struggling grad student, how are you doing on the homework problems? And I'm like, it's okay. Now that I'm saying this, I think I told this story before. But either way, even he looked at it, and he was like, I wouldn't even touch number 7 or number 8. I don't think he knew how to do number 7. And number 8, he said, that one's kind of like, that question is enough to do like a PhD on. And I'm like, holy crap, what's he mean? This is supposed to be a summer course, not get a PhD in 5 weeks type of thing. So the way the homework worked, though, you didn't have to do all the problems, obviously. Really, they were just, these are the problems that will show up on the exam. You pick 2, and then obviously you want to pick 2 harder problems that are worth more overall in the course. So you try and choose the 2 hardest ones you can to get the most amount of points. I think I've told this story on the channel before, so I don't want to rehash it, but TLDR, the course was so demanding that I really didn't get any research done in those 5 weeks. And my advisor understood, because he knew how demanding the course was. His friend was the one that taught the course. But after the semester was over, there was a lot of blood, sweat, and tears that semester. I'm not going to lie. That summer semester was also tough. This year was tough, now that I'm thinking about it. It started out with functional 2 that was bad. It went to the linear algebra condensed summer course that was just so demanding. And I've taken linear algebra twice, like up to that point. So I guess 3 times the charm, I guess. Get the most advanced version of linear algebra I could get. And then after that, I had what? What did I do? I went to Spain. Yeah, I forgot about that. I went to a conference in Spain. I made a couple videos about that. Learned some interesting things at the conference. Met some nice people. Unfortunately, that also cut into my research time. And I did not get to do the candidacy in summer like I planned. So when the semester did start, I went to my advisor and said, hey, we got to pick a date. And we decided October. But it turns out the fall semester was so demanding as well. Because I had the topology course. I took complex 2. I took the measure seminar. I had to teach pre-calculus. And then at the last minute, they gave me an assistant course. I had to assist an intro stats course, which stats is not my background. So I had to basically learn the material along with the other people. And I know it's intro stats, it's not that hard, but it's still time and energy that you have to put into it. So all those things put together, it's like, where are you going to get the time to do research? And so I find myself in this situation where I haven't done my candidacy yet, but we do have a date as of now. It's going to be January the 13th. Start out 2025 strong. And I know what a lot of you may be thinking right now is like, wait a minute, you don't have any time to do research, but you have time to do this MIT Open course. Well, that's why I spent a week just taking vigorous notes instead. So now at this point, yes, I do need to start focusing on what I'm going to present. As long as we have like an idea of what we want to do, that'll be good enough, I think. But I do need to at least collect my thoughts, put some pen to paper, and have something to show my advisor come January 6th or something. We're probably going to meet right around there. But that was 2024. Anything else I want to say? It's been about 20 minutes. It's usually where I quit the video. I mean, I went to California with family over the summer as well. That was before the semester started. That was like right at the end of spring semester, I think. It was like May or June, I can't remember. But it was fun. I want to do more traveling. Oh, I went to, Brown University, Harvard, all that stuff. But that's recent stuff. I don't want to talk about stuff I just did with my friends. So, anyway, I'll continue to keep you updated. You probably won't see another video before 2025, so I'll see you all next year.